Hey, this is Mark Lickman. I'm going to talk about some work that's being done related to the DIFI certification working group and the GitHub repo. So this GitHub repo currently has the Wireshark dissector, a tutorial, and then the DIFI validator code, which previously had ways to parse packets, both from PCAP and live over the wire. It has a web GUI. It does not yet support the latest versions of DIFI. So what we're doing is a bit of a cleanup and restructuring of this code, in part to prepare us for building a tool that can be used by vendors to check their software for DIFI compliance. So we want to be able to handle multiple versions of DIFI easily. We also want to have a list of validations for each type of packet, and then the ability to process either a PCAP or a live stream, and then compile a list of all errors that occurred. So what I've been doing is finding a cleaner way to have our packet definitions. Currently, the packet definitions, for example, the context packet, is defined in sort of just straight Python as far as parsing out the different fields, which is fine. And then at the bottom, we have some validators. But what I've been doing is playing with a Python package called construct, which is designed for defining a packet structure, really any data, packed data structure with different fields. And then it has the ability to parse bytes or generate packets from like a Python dictionary. And this has actually been working out very well. Let me show you the construct definition of the DIFI context packet that I put together. So it has a very concise definition. Every field has a data type, and then you can choose to enumerate them out if you want to. For example, this field is only 2 bits, but we can have a string associated with each value, or just some of the values. And this is called the construct definition. The groupings that you see are just for convenience sake. You don't have to group them. A bit struct is just kind of a container. But when you end up parsing creating an object after parsing some bytes, it's more convenient for accessing these values, having this container. So for example, if I wanted to parse the set of bytes, which I know is a good context packet, after that definition has been created, I can call the parse function. And this gives an object. It's not a Python dictionary, but it acts very similar. You can loop through all the keys and values and print them out here. So you can see this parsed the packet, and it gave me all of the values here. The ones that are enumerated, you get both the string and the number. Oh, and one cool part that I left out, if you look at some of these data types, you might see it's called scaled. This was a custom data type that I added. And the way that works is it automatically scales the value in both directions, both when you serialize and deserialize. For example, the bandwidth field needs to be scaled by 2 to the 20, before it's put on the wire, and then scaled back when you read it. So construct has this method of specifying the data type, in this case unsigned int16, and then the scaling in both directions. So we're using that here. It's working out very well. And it means that once we parse the packet, the value of bandwidth is already scaled. So in this case, 800 kilohertz. Very convenient for DIFI. The enumerations are really nice. And then if you wanted to, work with the object that's been parsed in Python, here's an example. I can look at the part of the data packet format that tells me if it's real or complex. So in this case, it just printed this out. Now, it was using the string here, but there is some way to get if you wanted the actual value instead. There's a way to do that I forget. The other really cool thing about construct is it comes with this graphical editor. So in this example here, I'm importing that context definition, and then I've got an example packet here. And if I run this example with the editor, it built this kind of Wireshark type hex editor just based on the construct definition and then the actual packet that we parsed. So for example, we can, if we click on one of these fields, it shows us at the top here, it shows us which bytes correspond to the header within the whole packet, the highlighted ones. And then within the header, which bits correspond to that field. So you can see it highlights that for you. And then you can even change the value. So I could switch it to a 2 here. Oops. And now it's a 2. And it's just kind of a nice, convenient method if you want to craft packets. So what we're going to do is, you can see I've already started to create the construct definitions for the different types of packets. For example, here's the data packet. And the plan is to have one of these files for each type of packet and each version. And then in addition to the actual packet definition that can be used for parsing, we also have a list of validations. There's more validations for the context packet here. So every packet type will have this list of validations. Ideally, they're one-liners, and then each one has a string that it will add as sort of like an error message. We don't want to just raise an error and quit. So we want to be able to compile the list of issues that pop up when someone's testing either a PCAP or a live feed from their device. Now this would represent a device that produces DIFI, and then this program is parsing out the fields. But the certification working group also has plans for the other direction, where something that takes in and consumes DIFI can be checked. So that'll most likely be with some example DIFI PCAPs, or just a script that creates them on the fly, given a set of parameters. So that's pretty much it for this. It's currently a work in progress, and we want to get feedback from folks on, you know, how they like this idea of using construct. I think that this will provide a lot of value, because if you look at the DIFI specs, the actual packet structure, it does show you sort of the bits and the bytes, but it doesn't give you a ton of information about the data types. Like, is it, signed or unsigned integer? Sometimes it's in the description, but other times you have to reference the VITA 49 documentation. So there's a lot of different places to look. And if you're like a software developer just trying to build like a parser or understand something, being able to reference something like this, where it's like fairly self-explanatory and intuitive, is a great way to go. So the idea is we can simply refine this definition, maybe adding some comments about any nuances with any values over time. And that'll be hopefully it'll be a valuable resource for developers, even if they're not in Python.